Welcome to The Explainer. Today, we're unpacking a brilliant little mini mystery from the world of software development. We often think of major software upgrades as these massive, sweeping overhauls, right? Thousands of lines of new code. But today we're looking at a microscopic code refactoring. We're going to see how a change involving literally a single tiny character yields massive program safety gains. It's an absolutely fantastic lesson in precision, and I really can't wait to share it with you.
Okay, let's dive into this. We're looking at two import statements here. The original is for a function called decodeUtf8, and right next to it is the updated version. This actually comes directly from part 155 of a fascinating series called Notes-on-Haskell-programming by a developer named Ang. Now, if you blank, you might honestly miss the difference. It's literally just one character appended to the very end of that second function name. A simple apostrophe, a tiny little tick mark. But in the world of Haskell programming, man, that little mark carries a tremendous amount of weight. Which naturally brings us to the core question. So, what difference does a single quote actually make? I want you to think of this as the ultimate butterfly effect in coding. Like, how could one tiny, almost invisible appended character possibly prevent a catastrophic failure in our software? It's kind of wild, right? It seems almost absurd that a modern application's stability could hinge on something that honestly just looks like a typo. But as we all know, in programming, precision is absolutely everything. That single character isn't a typo at all. Actually, scratch that. It's more than just not a typo. It's a deliberate, highly powerful command that completely changes how the program behaves under stress.
Now, what's really interesting about this slide is the definition of that character itself. In Haskell, that single quote is known as the prime symbol. You might recognize the prime symbol from high school math class to denote a derivative, like f prime of x. Well, in Haskell, it's essentially just a naming convention. Appending the prime symbol to a function name simply indicates to the reader and the compiler that this is an alternative version of that original function. It's basically a shorthand way of saying, hey, this is related to the original, but it just does things a little differently.
But here is where it gets a little wild. The source notes that the usage of the prime symbol is notoriously inconsistent across the Haskell ecosystem. So it doesn't mean just one set thing. Sometimes it denotes a much stricter version of a function evaluating data more rigorously. Other times, well, it's just an internal helper function meant to be used behind the scenes. But for our specific case today, the prime symbol is stepping up to act as the hero. In our context, it signifies a safer, much more robust alternative to that standard decoding function.
And this brilliantly illustrates exactly what we mean by safer. Let's contrast these two approaches. First, we have the original, kind of reckless path, decodeUtf8. If you feed this function an invalid document, it just throws a runtime exception. It completely panics. But then we have the safe path, decodeUtf8 prime. Instead of panicking, it returns what's called an either type. It neatly packages up the result, basically saying, hey, either I successfully decoded this, or here is the exact error that happened. It hands all that control right back to the programmer for safe handling instead of just blowing up the whole process. So the absolute crucial point here is the high stakes of the problem we're solving. Like, why does this even matter? Well, because if the content of a parsed text file is not a valid UTF-8 document, maybe it got corrupted or maybe it's just in the wrong format, that original function simply gives up. It triggers a runtime exception and literally crashes the entire application. Just imagine that. An entire system going offline just because a single text file had a few weird characters in it. No way. That is the exact nightmare scenario the developer Ang was trying to avoid with this tiny refactoring.
All right, here we have the actual code autopsy, the real diff, straight from the developer's notes. This is pretty much the climax of our mystery. Looking at the old way, we see the code simply assumes everything is going to go perfectly. But looking at the new approach, we see the real trade-off for our newly found safety. Because, we don't just magically get safety for free. We actually have to change the code to use a case statement with our new prime function. By switching to that safer alternative, the developer now has to explicitly write out the logic, just to deal with those potential errors.
Let's move to and see how this builds into a concrete logical flow. Step 1. The developer actively switches to the decodeUtf8-prime function, fully embracing that prime symbol. Step 2, because of that specific switch, the program now receives an either type, instead of just assuming it's going to get raw, perfect text every single time. And finally, step 3, the developer must now handle those decoding errors explicitly using a nested case statement. It literally forces the developer to answer the question, okay, what do we do if this fails, way before the program is ever allowed to run.
This brings us right to Ang's core takeaway from the source material. They write, another day, another tiny refactoring. To handle decoding error, we need to modify the code by introducing another nested case statement. I absolutely love this quote because it perfectly captures the day-to-day reality of software engineering. True code safety, it isn't free. It requires work. It requires explicitly taking those invisible, unexpected errors and making them visible so you can actually handle them gracefully. That little prime symbol, it just forces you to be a much more responsible developer.
Which leads me to leave you with this final, somewhat provocative thought. Take a look at your own projects. Think about the tools, the functions, the libraries you're using every single day. Are you blindly trusting the default reckless paths? Where is a missing prime symbol, or, your language's equivalent of it, hiding a runtime crash in your codebase right this very minute? I challenge you to go back to your work today, hunt for those vulnerable spots, and explicitly seek out the safer, more robust alternatives. Thank you so much for joining me on this explainer, and hey, happy coding!